Hello, Nova Online Math 161. Today we're looking at section 3.3, topic 3, graphing logarithmic functions. Use transformation to graph the function. State the domain and range in interval notation. State the equation of any asymptote. So we have to do 4 things here. So we need to find the domain. We need to find the range. We need to find the vertical asymptote. And we need to graph it. The wording said, state the equation of any asymptote. Log functions will have vertical asymptotes, and they depend on the horizontal translation. So I am going to write a basic function, y equals log base 6 of x, and tell you that this function has a vertical asymptote at x equals 0. Okay, vertical asymptote at x equals 0. Okay, so that's like a default vertical asymptote without any horizontal shift. But take a look at our function right here. Log base 6 of x minus 4, right? So because of that minus 4 inside, remember the section 1.6 on transformation of function, we have a horizontal shift. We have a shift of 4 units to the right. Okay, so when the graph is shifted 4 units to the right, its vertical asymptote will also shift 4 units to the right. So the vertical asymptote is not at x equals 0 anymore, but if you go 4 to the right from 0, well, the new vertical asymptote is now going to be at x equals positive 4. So we found the example, the equation of the vertical asymptote. Let's talk about the domain next. Domain. Let me erase some of this work. Remember, to find the domain of a log function, you must set this log argument greater than 0. So to find the domain, you'll say x minus 4 must be greater than 0. Log argument cannot be 0 or cannot be negative number. It must be bigger than 0. So if you solve this by adding 4 to both sides, we get x is greater than positive 4. And what does that look like in interval notation? So we're talking about not including 4, but everything greater than 4, so to the right side. So if you want to write that in interval notation, that will be from 4 to positive infinity, because if you keep on going to the right. So we found the domain. Now, range of any log function is always going to be negative infinity to positive infinity. Why? Well, remember, logs are inverse of exponential functions, right? So in section 3.2, we talked about domain of exponential functions, any exponential functions. And they are all real numbers because, I mean, here's an example. Y equals 2 to the x power. There's no restriction on what kind of number can be on exponent. And we can put any number to be on exponent and to evaluate the power. So domain of exponential function is all real number. But when you make the inverse, the domain and range switch, right? So that's why it's easy to just kind of memorize that range of a log function is always going to be from negative infinity to positive infinity, all real numbers. So we found the domain, we found the range, we know the range, and the vertical asymptote. The last thing we need to do is just to graph this. So let me see, let me just copy this down here so that we can graph it. Okay. So let's draw x-axis and y-axis. Here's the x-axis and here's the y-axis. But we know this graph is shifted 4 units to the right because of that horizontal translation. 1, 2, 3, 4. So we will draw a vertical asymptote at x equals 4. There we go. All right, we just need to plot maybe, now this question didn't really say how many points to plot. So let's just plot maybe 2 points, okay? Let's plot 2 points on this graph. So I'm going to plug in some x values to find the y value so that we can plot points. Remember, the domain says x has to be bigger than 4, right? So I can't plug in 1, 2, 3 or 0. I can't plug in 4. It has to be a number bigger than 4. So what's the smallest number that is bigger than 4 that we can plug in? An integer will be 5, right? So I'm going to plug in 5 into this function to see what we get, okay? We will have log base 6 of 5 minus 4, which is log base 6 of 1, and that is just 0 because, well, let's think about this. If I give you the exponential form, 6 to the 0 power equals 1, and that is true, right? But let's say that, you want to use a calculator to evaluate the log. Remember, 3, 3. Well, in next section, you are going to learn about a formula called change of base formula. You can use that to find the exact value. But at this point, we're just thinking about 6 to the what power is equal to 1? And the answer is 0. That's how we can evaluate this log expression. So what I'm going to do is I'm going to plot a point at 5, 0. So we will plot 5, 0. So go 5 to the right, and at 0, we'll have our first point. Let me plug in one more number. I just want to do one more maybe. Let's think, what will be a nice number for us to plot? Because guys, it's a little tough because if you think about 5, 6 to the 0 power, you will get 1. And the next number will be 6 to the first power equaling 6. So I want to make the log argument to be 6. So take a look. What if I put 10 here? What if I put 10 into this function? If I plug in 10, then I'll get log base 6 of 10 minus 4, which comes out to be log base 6 of 6. And if you think about 6 to the what power is equal to 6, we know the answer is equal to 1. So the second point that we can plot is 10, 1. And I'll go 10 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and go up 1. And here's the second point. I think that's enough for plots, but we will sketch what this log function should look like now, okay? So this graph will keep on increasing to the right. Kind of slow, but it will keep on going to the right. But what will happen to the left end is that, remember that it is bounded by this vertical asymptote at x equals 4, right? So it's not allowed to cross it to go to the other side. So we are going to just drop a tail, but make sure that tail is getting really, really, really close to that vertical asymptote, but it will never cross it or touch it, okay? So that's going to be the graph of this function, f of x equals log base 6 of x minus 4. But I think if we are just using the transformation of function, we could have just put one plot at 5, 0, and just sketch the graph, because it was really kind of difficult for us to figure out what's going to be the second nice point to plot. But, just thinking about what are some possible numbers we can get by raising 6 to the to an exponent. So my next point would have been something like this. If I do 6 squared, I know I'm going to get 36, right? So I am going to be thinking about what should I plug into this argument x minus 4 to get 36? And I would have totally done what, 40 as my next x choice. But we will not be able to graph it in a small graph like this, right? So I think it will be, if you're taking your exam, I think it will be fair for us to just maybe plot the first point, okay? And then clearly graph the vertical asymptote and sketch the function, especially if the log argument is anything like greater than 6, 7, 8. The numbers, the x values kind of get very big quickly.